Okay, so now on to example 3. We're going to keep going with that. We've got our steps on factoring, which is finding the greatest common factor of all the terms. So to do this problem, we've got 27x subtract 9x squared, and we want to find the greatest common factor of both of those. Okay, so looking at the numbers first, we've got 27 and 9. The greatest common factor between those numbers is 9, and the greatest common factor of the x is an x. Okay, so the greatest common factor we have is 9x. So let's write it out front, and then we've got to fill inside the brackets. Remember, there are two terms here, so there should be two terms in the bracket. So we're going to divide 27x by 9x, and we're going to get 3. And then we're going to divide 9x squared by 9x. So 9x squared by 9x. Okay, so x squared divided by x is going to be x. And 9 divided by 9 is 1, so 1x, or just an x. Okay, so we're going to put x. So that the factored form is 9x, and 3 minus x. Okay, so that was example 3. Remember, every question we're going to do these same 3 steps. So let's look at example 5. Now, we have the difference in example 5. We're still going to do the same 3 steps, but we have now 3 terms. So there's 1, 2, and 3. The terms are minus 2x squared, minus 4x, and positive 6. So the same first step is going to apply. Find the greatest common factor of all the terms. Now we have 3 numbers and 3 terms to look for the greatest common factor. Now, right away we see a 2, and 2 is a factor of 4 and 6. And since 2, the greatest common factor here is going to be 2, because the biggest factor in 2 in itself is 2 anyway. So 2 and 2 and 2, so the value of the greatest common factor is going to be a 2. Now if we look at the x terms, there's only an x term in this one, there's an x squared, and there's an x term here, but there's no x term here. So we're not going to consider x a common factor of these 3 terms because it doesn't exist here. Okay, so the actual greatest common factor is going to be just 2. Okay, so the thing we're going to worry about, though, is that even though it's just 2, if the first term, if the x squared term has a negative in front of it, and the greatest common factor happened to be 2, we're going to take a negative out with it. So the greatest common factor we're going to look at is negative 2. So we're going to write it down out front, and we're going to fill in our brackets like for step 3. Now, we're still going to be doing step 3 by dividing by the greatest common factor, but we'll divide each term, which is in their 3 terms, by that minus 2. Okay, so minus 2x squared divided by minus 2 is equal to just x squared. So we'll write x squared here. And notice now this new term is not going to have a negative at the very beginning, okay, inside the brackets. Now to continue, we're going to take minus 4x and divide it by minus 2. Minus 4x divided by minus 2 is minus 4 divided by minus 2 is going to give us a positive 2. And x divided by, well, we don't have an x with minus 2, so it's going to be an x. And then the last term is positive 6 divided by minus 2, and a positive divided by a negative is going to leave us with a negative, and 6 divided by 2 is 3. So our factored expression, there's going to be 3 terms because we have 3 terms at the beginning, so there's 3 terms in the brackets. But this is our factored expression. Now looking at our last example, as usual we have our 3 steps. The difference between our steps here is it looks like it's almost factored. It looks like there's a factored expression here, and it looks like there's a factored expression here. But it's asking us to factor this whole thing. And if we look closely, if you look at this term, because this is one term, it's got 2 terms inside of it, but it's considered one term because it's this term subtract this term. So there are only 2 terms in this expression. Now if we look at what is common in both terms, we should see that there is an x plus 1 common on this side, and there's another x plus 1 common on this side. That's kind of like saying that, that's kind of like when we had, if we had 6 and in brackets, well, let's think about a different example. If we had So looking at that, there's common x plus 1 on both terms. So the greatest common factor of those two terms is going to be x plus 1. So we're going to do step 2. We're going to write the greatest common factor of x plus 1 out front. We'll put brackets around that because it's separate. It's a whole term right there, x plus 1, one term. Okay, and then what we'll do is we'll figure out what goes inside the other brackets. Now remember, there's two terms here, so there should be two terms here. So what we're going to do is divide each term, these two, by the result to get the result inside the brackets. So if I just do the first one, if we had 3x and x plus 1 divided by the greatest common factor, which is x plus 1, if we look at this x plus 1 divides with x plus 1. It's like they divide itself out to be 1, and we're left with 3x. So inside the bracket we get 3x, and then similarly it would be minus 2x plus 1 divided by x plus 1. That's going to give us a minus 2. Okay, and then that's our factored expression, x plus 1 times 3x plus 2. If I write it a little bit neater, there we go. Okay, so that's the factored expression. Notice it almost looks like, or it is it's called two binomials multiplied by itself, and it's going to be, it ends up being a quadratic, and we'll see that down the road. Okay, so now we know enough, we've seen enough examples that we can do the homework questions.